So welcome to Silicycle Scavengers webinar. Whether you are new or an experienced CiliMS user, this presentation will provide you tips and tricks about their use. First, allow me to introduce myself. My name is Catherine, and I work for Silicycle as technical support specialist for a little more than 3 years. Now, a few words about Silicycle. We've been purification expert for 27 years. We have a diversified portfolio, and our products are available worldwide. We have a strong R&D team made of experts from various fields to support product development of the highest quality. Our customer support team is devoted to your needs and always happy to help. You might be wondering if scavengers could be useful for you. If you work in the medicinal or pharmaceutical industry, you probably clearly see the importance of removing metals or PGI from your API. The electronic field is also not spared by metal contamination because residual catalysis can affect the performance and stability of electronic components. So now the kinds of molecules that can be scavenged. Silicycles offer solutions for metal scavenging, the CiliMS, and organic molecule scavenging, the CiliaBound. Let's establish now what a scavenger is. Basically, it's a silica solid support on which a functional group is attached with a linker. Solid support allows to simplify the workup by simply filter out the scavenger once the metal or the organic molecule is trapped. The linker connects the functional group to the silica beads. Finally, the functional group, the masterpiece of the scavenger, makes the scavenging possible and also determine the affinity of the scavenger. You might now wonder why you should integrate silica-based scavengers in your process, since you already use activated carbons for this purpose. In fact, activated carbons are also proved to be efficient for metal removal, but it is much less selective than silica-based scavengers. This results in a decrease in terms of yield, and after a long synthesis with multiple steps, the last thing you want is to lose product in the purification. Activated carbon might also not allow you to reach the required level of residual metals. In this case, a subsequent treatment with CiliaMS scavenger could allow to fine-tune the scavenging because of the higher selectivity. Customers often contact the technical support and ask, what is the best scavenger to remove this metal or this organic molecule? This is unfortunately impossible to answer this question. In fact, we can recommend some scavengers known to be good for this purpose, but since every chemical reaction is different, screening tests must be done with the scavengers to determine which one is the best for your own situation. Once you've selected the best scavenger, you might also have to undertake optimization steps to increase the scavenging efficiency. We will talk about these steps a bit later in this presentation. Tables like this one are available to help out choosing the scavengers for your screening test. For example, if you want to remove the residual nickel from a Kumada coupling or from a reaction requiring the use of Rhine nickel, 9 scavengers could be tested in order to select the most efficient one. We also have tables for organic scavenger selection. Now you have selected the best scavenger. You might wonder how to calculate the quantity to add. 2 different methods are suggested to calculate the amount of scavengers required: the molar equivalent method and the weight method. The molar equivalent method makes it possible to calculate the exact number of equivalents to add. However, it also requires having previously determined the level of metal contamination. On the other hand, the weight method would allow to skip the pre-analysis step at the expense of risking an overestimate of the quantity really needed. For the equivalent method, we recommend 4 to 8 equivalents as a starting point, and for the weight method, 20%. Then the quantity can be adjusted up or down as required. After screening tests whereby the most performant scavenger has been selected, optimization steps can be undertaken. There are 9 main parameters that can be adjusted either independently one at a time or simultaneously to improve overall scavenging efficiency. By experience, some are known to influence scavenging more than others, and have therefore been grouped in 3 main steps. First, the scavenging should be pursued until a plateau is reached. Then, the amount of scavenger can be adjusted upwards. Finally, the temperature can be increased up to 150 Celsius degrees. If the first step did not allow to improve the scavenging efficiency, then you could mix multiple scavengers together or perform subsequent treatments in filtering between each. Or if you have a very large quantity of metal to remove, you can pre-treat your solution with activated carbon prior to the scavenger treatment. In last resort, if you can try to change the solvent, increase the mixing rate, or modify the pH of an aqueous solution. CD cycles offer different formats for different applications, and it is yours to choose according to your needs. You might not have the time or equipment to perform the screening test by yourself. No problems. CD cycles offer R&D screening services. We offer 2 different plans. The basic one includes the screening test with activated carbons and scavengers, scale-up test, and complete report. The extended one offers the same test than the basic one, plus EPAC screening tests. Well, we hope this presentation has helped you to get to know the scavengers a little better. To dig deeper into the subject, many case studies and application notes are available. You can download them from our website. If you have any question, do not hesitate to write at support@citycycle.com. Our team will be more than happy to help.